Hello everyone. Hello everyone. Today, let us look into how to convert a perspective formula into a Fisher projection formula or vice versa. Okay, because many of the students found it a little difficult to understand how a perspective formula can be converted to a Fisher projection formula or the conversion of a Fisher back to the perspective formula. So here I'll tell you a technique of how to convert a perspective formula into a corresponding Fisher projection formula. So on your screen, as you can see here, I have drawn a hypothetical molecule, which is nothing but your bromochlorofluoromethane. Okay, so this compound, I have drawn it in a perspective formula wise, using a perspective formula, I have drawn this particular molecule. So when you want to convert this particular perspective formula into its corresponding Fisher projection formula, a simple way to do is consider this CCl bond, that is the top line bond, okay? And consider this particular axis, which is shown by dotted lines here, and rotate this molecule along this ClC bond by an angle of 90 degree in an anti-clockwise way. So when you rotate it by an anti-clockwise way, this Br will go on the back side. Okay, this Br will go on the back side. So you are rotating across this axis by an angle of 90 degree. Okay, so when you rotate by an angle of 90 degree, that is when you perform a C4, okay, C4 operation across the across the CCl bond. Okay, so when you perform a C4 operation across the CCl bond, what happens? The Br is pushed in the backward direction. So I'll use a model here. So you can see here perfectly this particular molecule. So this bigger one, bigger blue one is your bromine. Okay, and this one is the bigger one is your Cl. Okay, and then you have probably the other way around. Basically, fluorine is towards you. So I might have to interchange this molecule. So you have your chlorine here, bromine here, you have fluorine pointing towards you, and you have your hydrogen on the back side. So I'm so this palm is my the plane of the writing board. So Cl and Br bonds, they are on the plane. Okay. So in order to draw the Fisher projection formula, I have to bring the Cl and Br on the back side of this plane. So in order to do it comfortably on a two-dimensional plane to understand it, what I'll do is I'll rotate across this Cl C bond, that is this bigger green and this black C bond. I'll rotate by an angle of 90 degree in a backward direction. So when I rotate it in the backward direction, what happens? This Br will go behind. And while Br is going behind, what is happening? Your Cl is coming this side, and your H is, which was in the back side, has come to the front side. So both Cl, both your fluorine and your hydrogen has now come on the front side, while your Br, which you rotated by an angle of 90 degree, has now gone on the back side. Okay, so that is what is I have shown in this particular picture here. So if you look carefully here, what is happening? When you're rotating your molecule by an angle of 90 degree, the Br is going on the back side. So your fluorine is now coming to the front side, and your hydrogen is also coming to the front side. So fluorine, which is on the front side, will go towards the right side, and hydrogen, which is on the back side, is coming to the left side. So structures look similar, something like this. Now what you have to do, you have to just push this CCl bond little backward. So what happens? It automatically becomes a dotted line, and other bonds you do not touch. Okay. And once you reach this particular state, okay, once you make this particular molecule, it is very easy to convert into the Fischer projection formula. You just write a plus sign and then you write all these groups across these horizontal and vertical bonds. Okay, so let me do the perspective formula in another way around. So here your line bonds are on this particular side of the page. Okay, and now in order to make the Fischer projection formula corresponding to this particular structure, what I'll do, I'll rotate across this CCl bond by an angle of 90 degree. Okay, so by an angle of 90 degree means I'll perform a C4 operation across CCl bond. So across CCl bond, I'm going to perform a C4 operation. So when I perform a C4 operation and rotate this molecule like this across the CCl bond, this Br is now going to the back side. Okay, and fluorine, which is on the front side, has come to the left side, and hydrogen, which was behind, has now come to the right side. Okay, now what you do, you just push this bond a little backward, so it becomes a dotted line. Okay, rest of the things you do not change. Okay, once you reach this particular state, it is, you can easily convert them into the corresponding Fischer projection formula. Okay, so I hope you understood how to convert a perspective formula into a Fischer projection formula. Now I'll teach you how to go backward. You just follow, retrace this path. Okay, so if you have some Fischer projection formula like this, okay, what you have to do, you write this wedge dash formula, something like this first initially. Okay, once you write this, next step that you have to do is you push this upper bond, that is CCl bond, little bit front, so that becomes a line bond. That means a bond that is on the paper. Okay, after that, what you do, you will try to do a 90-degree rotation. Either you can bring Br here, or you can bring Br here, whatever is your way of doing. So suppose, since I'm making this particular diagram, what I'll do, I'll rotate my molecule in such a way that I'll rotate by 90 degree like this. That is, means I perform a C4 operation. So Br, when I rotate in a, like if I rotate in a clockwise way, the Br will be coming on the right side and it becomes a solid line like this. Okay, and then your hydrogen, so when you Br is coming here, the hydrogen which was on the left side is going behind, and fluorine which is on the right side has come to the front. Okay, so you can easily convert a Fischer projection formula to the corresponding perspective formula. Let us look at this particular molecule. Once you have this, you easily first convert it into this particular kind of wedge dash formula. Okay, then you push the CCl bond little bit up front so that it becomes a line bond. That means the bond that is on the paper. Okay, then in order to bring Br on the left side, what you have to do, you have to rotate this by anti-clockwise by a C4 angle. So when you rotate by using a C4 proper axis rotation, that is 90 degree, what happens anti-clockwise when you rotate it, the Br which was behind has now become a line bond. So when you rotate and bring Br here, your H which was on the left side has on the right side has now gone to the back side, and the fluorine which was on the left side, okay, has now come to the front side. Okay, so you can follow this particular pathway in the front direction. If you go, it leads to Fischer projection formula, and if you go on the backward direction, it becomes a perspective formula. So I hope you understood how to interconvert the Fischer projection to a perspective formula, or perspective formula to a Fischer projection formula. Thank you very much for your attention.